The liar paradox. This is one of the most famous logical paradoxes, which is connected to a statement that denies its own truthfulness. It goes like this: I am lying. If this statement is true, then its content is also true, but the content claims that it is false, so it cannot be true. If the statement is false, then what it claims that it is false must be untrue. Therefore, the statement is true. The liar paradox is a profound example of how self-reference, a statement referring to itself, can lead to irresolvable contradictions. The omnipotence paradox. Can an all-powerful being create a stone that it cannot lift? If yes, then it is not omnipotent because it cannot lift it. If no, then it is not omnipotent because it cannot create it. The time paradox. If you travel back in time and kill your grandfather before one of your parents is born, how could you have ever existed to do it? The Fermi paradox. There are billions of stars and planets in the universe, many of which could support life. So why haven't we discovered any alien civilizations? This contradiction between high probability and lack of evidence is known as the Fermi paradox. Zeno's paradox, Achilles and the tortoise. The fast Achilles cannot catch up with the slow tortoise if it has a head start, because he must first reach the point where the tortoise was, and by that time it has already moved farther ahead. From the point of view of physics, since Achilles is moving faster, he will of course catch the tortoise. The paradox of Zeno arises not from the laws of physics, but from a philosophical reasoning about dividing distance and time into infinitely many parts. Zeno creates the illusion of the impossibility of motion, showing that intuition struggles with the concept of infinity. Dichotomy. To cover a distance, one must first cover half of it, then half of the remaining half, and so on infinitely. Therefore, motion is impossible, because to reach the goal, one must complete an infinite number of steps. The arrow. A flying arrow, at every single moment in time, is motionless because it occupies a fixed position. If motion consists of such motionless moments, then motion itself is impossible. The Procrustean paradox. This paradox describes a situation in which something or someone tries to forcibly fit or adapt something to a predefined standard without taking individual differences into account. According to the myth, Procrustes was a bandit who lived in the mountains and lured travelers into his home by offering them a place to rest. He had an iron bed, but it was suitable only for people of a certain height. If a traveler was too tall, Procrustes would cut off parts of their body, and if they were too short, he would stretch them, trying to make them fit the bed. The Procrustes paradox shows that forcing everything to fit a single model or standard leads to loss and harm because it ignores diversity and unique characteristics. The twin paradox. One of the twins travels through space at a speed close to the speed of light, while the other remains on Earth. When the traveler returns, they realize that they have aged less due to time dilation. Although, according to classical logic, both twins should be the same age. The Monty Hall paradox. 3 doors problem. You have 3 doors. Behind one of them is a prize, for example a car, and behind the other 2 are goats. You choose one door, but it is not opened yet. The host, who knows where the prize is, opens one of the 2 remaining doors, behind which there is definitely a goat. After that, the host offers you to switch your choice to the other unopened door, or stay with your original choice. Many people think the chances are 50-50, since there are 2 doors left and one of them has the prize. But in reality, if you switch, your chance of winning is 2/3. If you stay, your chance is only 1/3. The friendship paradox. This paradox states that most people have fewer friends than their friends do. At first, this seems illogical, since every friend is part of someone's social circle. The paradox occurs because people with a large number of friends appear more often in the friend lists of others than those who have fewer friends. The progress paradox. Technological progress creates more problems than it solves. Every new solution leads to new difficulties. For example, the internet and social media have greatly improved access to information and communication, but at the same time, they have contributed to the spread of misinformation, cyberbullying, and addiction to digital devices. The freedom paradox. Complete freedom leads to the loss of freedom. For example, if everyone can do anything they want, stronger individuals may dominate weaker ones, limiting their freedom. Simpson's paradox. This is a phenomenon in statistics where, when there are 2 groups of data, each showing the same type of relationship, combining these groups can reverse the direction of that relationship. For example, data from a group of people may show that a certain medicine increases the chance of recovery. However, if the group is divided into 2, men and women, it may turn out that the medicine actually decreases the chance of recovery in each group. Moore's paradox. It sounds like this: it is raining, but I don't believe it. The statement includes 2 parts. It is raining is an objective statement about a fact, while I don't believe it is a subjective expression of disbelief. The paradox is that stating both at the same time seems illogical. illogical, because if you say that it is raining, it implies that you believe it. Schrödinger's cat paradox. Imagine a box where a cat's life depends on an atom that may randomly decay or not. If the atom decays, the cat dies. If not, the cat remains alive. Before you open the box, the cat is both alive and dead at the same time in a state of superposition. But as soon as you look inside, you will see either a living or a dead cat, and the superposition disappears. This illustrates that in the quantum world, the state depends on observation. The birthday paradox. The probability that in a group of 23 people there will be at least 2 with the same birthday is greater than 50%, which intuitively seems incorrect. Intuitively, it seems that many more people would be required for birthdays to coincide, since there are 365 days in a year, and the probability of a match should be low. However, due to the large number of pairs that can be formed in a group, the probability grows very quickly. The dictator paradox. Democracy allows the majority to choose a dictator who can destroy democracy, thereby undermining its foundations. The Sorites paradox. If you remove one grain from a heap, it remains a heap. Removing grains one by one, at what point does the heap stop being a heap? The Raven paradox. Hempel's paradox. The hypothesis, all ravens are black, is logically equivalent to the statement, all non-black objects are not ravens. Therefore, observing a red apple, a non-black object that is not a raven, formally confirms the hypothesis. Intuitively, this seems absurd, since apples do not appear to be related to ravens. The knowledge paradox. The more you learn, the more you realize how much you still don't know. Knowledge leads to an awareness of one's own incompetence. The solipsism paradox. If you can only be certain of the existence of your own consciousness, how can you be sure that other people truly exist? The paradox is that if everything exists only in your mind, how can you explain the existence of other minds or interactions with the external world? Moreover, the very act of discussing solipsism with someone puts this idea into question. If everything is part of your mind, how is it possible to receive new information? The crocodile paradox. A crocodile steals a child and promises to return it if the mother correctly guesses his intention. If the mother says that he will not return the child, a logical contradiction arises. The situation creates a logical loop. Fulfilling the crocodile's promise makes the mother's prediction wrong, while not fulfilling it makes it correct. The barber paradox. In a village, there is a barber who shaves only those who do not shave themselves. The question arises, does the barber shave himself? If the barber shaves himself, then he should not shave himself according to the rule. If he does not shave himself, then he must shave himself according to the rule. This leads to a logical contradiction. The satisfaction paradox. The more you try to find satisfaction or meaning, the less likely you are to achieve them. Russell's paradox. Imagine the set of all sets that do not contain themselves. The question is, does this set contain itself? If it does contain itself, then by definition it should not contain itself. If it does not contain itself, then it must contain itself, since it fits its own definition. This results in a contradiction. Gibbs's paradox. When identical gases are mixed, there is no change in entropy. But if they are different, entropy increases, which seems like a contradiction. Newcomb's paradox. The essence of the paradox is this. Before you stand 2 boxes. Box A always contains $1,000. Box B may be empty or contain $1 million. You can either take only box B or take both box A and box B. There is a super intelligent predictor that can predict your actions with very high accuracy. If the predictor believes you will take only box B, it puts $1 million in it. If it believes you will take both boxes, it leaves box B empty. Your choice is to take both boxes A and B, or only box B. Newcomb's paradox calls into question our understanding of rationality, prediction, and causality. It continues to provoke debate among supporters of different philosophical approaches to decision-making. The Banach-Tarski paradox is a mathematical paradox that proves a sphere can be divided into a finite number of pieces and reassembled into 2 spheres identical to the original in size and volume. It is based on set theory and the axiom of choice, which makes it counterintuitive and difficult to grasp. The Banach-Tarski paradox demonstrates the power and strangeness of mathematics and calls into question our intuitive understanding of space, volume, and divisibility. Condorcet's paradox. In voting, the preferences of a group of people can be cyclical. A is preferred to B is preferred to C, but C is preferred to A, making the collective decision illogical. This paradox appears in politics, economics, and other systems where collective decisions are made. It demonstrates that simple majority voting is not always fair or effective for making choices. The black hole information paradox. According to quantum mechanics, information does not disappear. But black holes, by absorbing matter, supposedly destroy information, which contradicts the fundamental principles of physics. The confidence paradox. The more confident you are in your understanding of something, the more likely it is that you are missing something. Complete certainty often leads to mistakes. People who are confident in their correctness are less likely to double-check facts or consider alternative viewpoints. Those who doubt their knowledge are more likely to verify their ideas and are more open to criticism, which increases the likelihood of them being right.